Hello, B-Sides, and thank you for attending my talk, Chats, Cheats, and Cracks, Abusive Collaboration Platforms and Malware Campaigns. So today I want to talk a little bit about some of the changes that we've seen in employee workflows and corporate communications since the start of the COVID-19 pandemic and kind of some of the impact that it's had on the global threat landscape. I want to talk about how some of the collaboration platforms that organizations are now heavily using for official community communications, employee communications, and things like that are being abused by adversaries throughout different stages of the malware lifecycle across different malware campaigns, different malware types, and things of that nature. I want to kind of break it into three kind of main phases of your standard malware infection. I want to start out by talking about malware delivery, or how the malware is initially getting to the victim. Then I want to talk about component retrieval, which is kind of what happens during and after the infection process is occurring. So in a lot of cases nowadays, right, malware infections aren't single stage individual files being delivered to a victim. In many cases, the malware infection process takes place over multiple distinct stages with various components being delivered to different systems throughout the infection lifecycle. And then I want to finish by talking a little bit about command and control and some of the post-infection communications, data exfiltration, and things like that. So just a little bit about myself. My name's Edmund Brumaghin. I am a security researcher with Cisco Talos. So I focus on malware research and threat intelligence. So I love malware. That's what I spend my time working with. While a lot of folks spend their time trying to prevent malware infections, I find that I spend a lot of my days trying to infect systems with malware intentionally so that I can analyze it, figure out what it does, and help keep our customers safe. I've been with Talos for over 5 years now. Prior to that, I spent a decade in security operations. I've held pretty much every role you can hold on a SOC team, up to and including team leading security operations teams. Also like to do embedded systems research, IoT related research, and things like that. It's something that I find very interesting and love learning more about. So let's dive right in. Let's talk a little bit about what we've seen since the COVID-19 pandemic started. So obviously one of the major shifts for a lot of organizations was the move to kind of remote employment situations where employees are working remotely, where in the past they may have been sitting in an office with their coworkers. And so one of the natural byproducts of this change has been that organizations have had to increasingly rely on collaborative communications platforms to facilitate employee communications so that coworkers can discuss work-related topics. So two of the biggest platforms that we've seen kind of be adopted throughout the pandemic have been Discord and Slack. So Discord, right, that's where this event is being held. It's being used increasingly for a lot of professional types of communications. Historically, it's mainly been used in kind of the gaming community and in hobbyist organizations to allow different individuals to communicate. But nowadays, it's being used for a lot of professional events as well. Security conferences. If you think of a lot of the virtual conferences that we've held over the past year and a half or so, a lot of them have taken place with the primary means of communication being Discord. That's how attendees are able to communicate. That's how speakers are able to answer questions. That's how events are coordinated. So we're definitely seeing it in more than just personal communications capacities. It's being used for professional purposes as well. It's one of the largest communications platforms out there. According to Discord at the time that we really kind of dug into how these platforms are being used, they boasted about 140 million monthly users. So the footprint is pretty wide for Discord. Another one of the very common platforms out there is Slack. This is kind of been geared more towards professional communications. It's used in a lot of organizations to allow team-based collaboration and things of that nature. Right now, they boast about 10 million daily users. So again, the user base is pretty significant, and it's only exploded in popularity since it's kind of been necessitated by the change in employee workflows that we've seen over the past year and a half. So one of the natural byproducts of new platforms gaining popularity is that adversaries are constantly on the lookout to try to identify ways to leverage this newfound popularity, to leverage these platforms for nefarious purposes. And in the case of Discord and Slack and other collaboration platforms, we've seen it heavily abused by a variety of different threat actors for the purposes of malware distribution. So this slide just kind of gives you a list of a few of the different malware families that we've seen leveraging either Discord or Slack at some point throughout the infection process. You've got stealers like Agent Tesla. You've got remote access Trojans like Async Rat, Nanocore. Some of the commodity malware that we see pretty heavily distributed across the global threat landscape at any given point in time. But one of the major shifts we saw was increased reliance on the part of nefarious actors on these collaboration platforms to facilitate the infection process and also to manage the infections once they've occurred and the systems are under the threat actor's control. So let's start with talking about malware delivery. I kind of mentioned this earlier, but this is really referring to how the malware is initially being delivered to the victim, how it's making its way to systems to initiate the infection process. So one of the things that really needs to be understood is kind of how some of the functionality takes place within these platforms, because it makes it a little bit more understandable as to why it's been viewed as such an attractive mechanism for adversaries. So if you take the example of Discord, right? Discord supports, servers. Anyone can sign up with an email account. They can create new servers, and within those servers, they have channels, and that's the primary mechanism that's used to communicate between different members of the server. So Discord supports the attachment of different contents within these server channels that may have been created by the server administrator, but are free to create. Anyone can create as many as they want. There's really no limitation, no barrier to entry. So when you attach files within Discord channels, one thing that not a lot of people realize is that there aren't any access controls in place on that content. So in this example, I created a Discord server, and inside the Discord server, I created a channel called Dumpster Fire. So in this example, I just attached an animated GIF of a dumpster fire, right? It's very fitting. But the thing about attaching contents within Discord is that if you know the URL to the location where that resource is actually housed on the content delivery network, you don't have to be a member of the server. You don't even have to have Discord installed. But if you know that URL, you can access that content directly. Something to keep in mind, even as a Discord user, that if you're attaching files or other content that maybe you meant only for the members of that server, there's really nothing in place to prevent anyone else who has access to that URL or knows what the URL location is from accessing that same content. So malware distributors have recognized that this is really attractive for malware distribution. So, right, instead of an animated GIF, they can attach a malicious file, a Word document, or any other sort of content that they would like to be able to distribute, and they can take advantage of the same functionality. They can create a server, attach their content, retrieve the CDN URL, and then use that in their distribution campaigns. And one of the direct byproducts of taking this sort of an approach is that now adversaries are able to deliver potentially malicious content to potential victims over a TLS encrypted communications pathway. Likewise, they're able to host it on a legitimate domain. So if you're looking at this and you're trying to identify detection possibilities here, it looks just like any legitimate Discord-based communications look. The files are being served directly from the Discord content delivery network over TLS encrypted tunnels. So it presents a variety of different hurdles for defenders that are trying to prevent this sort of activity from reaching their users. It can circumvent a lot of perimeter security controls that an organization may have in place. So I don't want to just pick on Discord, right? Because it's not the only platform that supports this functionality. Slack supports the exact same functionality, right? An adversary can create a Slack instance. They can create channels within the Slack instance, and then they can attach files there. Now, one of the main differences with Slack is that you actually have to do something for the files to be publicly available. So in the case of Slack, you attach content to the Slack instance and you generate a public link for the file. You can see an example of that on the slide here, where once you've attached content, you generate a public link, and then anyone on the internet that's able to access that URL, they don't need to be authenticated to the Slack instance. They don't need to have Slack installed. They can access these resources from any system that they want. So here's an example of another animated GIF that I attached to a Slack instance, generated a public link just to kind of demonstrate that it's as easy as accessing any other HTTP-based resource on the internet. If you know the URL, you can access the contents, and they're hosted on legitimate domains. Again, they're retrieved over TLS encrypted tunnels, so they present a lot of the same hurdles for defenders that Discord does. So in both cases, adversaries have recognized that this functionality is available, and they've begun leveraging it to kind of facilitate that delivery process to get the initial malicious contents to potential victims. So this is happening. It's not isolated by any means. We're seeing a tremendous explosion in the volume of this activity that's being seen across the threat landscape. Just to kind of give you an example of just the volume, when we did the initial digging into the types of campaigns, the types of activity, how much volume we were seeing, you could go to VirusTotal, a pretty widely known malware repository, and you could simply do a behavioral search for any samples that reach out to the Discord content delivery network. And you can see at the time, there was about 17.5 thousand distinct samples. So just kind of shows you what that activity was around the end of April, beginning of May. So as I was putting this presentation together, I went back and just did a more recent check from, within the last week. And I noticed that at this point, there are, over 36,000 distinct samples just present within VirusTotal that exhibit this behavior. So just kind of shows that this is pretty widespread at this point. There are a lot of adversaries that are starting to take advantage of this functionality because, it affords them a lot of the benefits I've, previously described, as far as being able to encrypt the contents that are being delivered, as well as being able to host them on legitimate, server-side infrastructure that may not be blocked in a lot of organizational environments. So just to kind of put it in perspective, here's a couple tweets from late last month in August from abuse.ch, where they were even then identifying wide-scale abuse of this functionality. In this case, these were Dridex campaigns that were being hosted on the Discord CDN. Again, it's become very attractive, and as a result, we've seen an explosion in this type of activity. And once again, not just to pick on Discord, we're also seeing the same activity leveraging the Slack content delivery network as well, right? As these platforms have gotten popular, they're not just popular with the organizations that use them; they also become popular with nefarious actors as well. So one of the primary mechanisms we've seen this delivery phase is with the use of email. That's one of the most common initial attack vectors that we see using this sort of functionality. You can kind of see a snapshot of some of the volumetric information within our telemetry, as far as the sheer volume of emails that contain resources that reach out to the Discord content delivery network or the Slack content delivery network. And you can see it was fairly steady, fairly low volume up until around the April 2020 timeframe. Again, that coincides around with when a lot of the remote work from home type of arrangements were being implemented, and more organizations started to heavily rely on this technology. And this trend has continued. We're continuing to see this explosion because it's attractive to adversaries, and as a result, we're seeing more and more malware campaigns that are leveraging it. So one of the main techniques we've kind of seen from email-based attacks that leverage this is the use of compressed archives. So the idea here is that the adversary will send an email to a potential victim or a group of potential victims, and those emails will contain links to resources hosted directly on Discord or Slack's content delivery networks. And in a lot of cases, we were seeing the file formats being used were various compressed archive file formats using a variety of different compression algorithms. When you think about it, it makes a lot of sense, right? They put a link to it in an email. That link points to a compressed archive, so that when the content's being delivered to the victim, a byproduct of the compression process is that it obfuscates the contents of the data that's being delivered, right? When you think about a zip archive or something of that nature, when you look at it, you're not seeing strings. You're not getting a lot of clues as to what the underlying functionality might be to be able to deduce whether or not it's malicious or benign in nature. And so that's kind of one of the main strategies we've seen adversaries leverage. Is they'll compress the contents, they'll host it in Discord or Slack's content delivery network, and then they'll put a link to those files in their emails and send them to victims. So here's an example of a German email campaign that we observed when we were doing a lot of the research into how this is being abused. You can see it's fairly standard malicious spam or mal spam, right? They're trying to convince the victim to open the attached file. In this case, you can see there's an image there. It looks like a PDF is being attached to the email. But they did something a little bit different, right? That's not an actual file attachment. What they did was they basically created a hyperlink to an ISO archive that was being hosted on the Discord content delivery network, and then they used a placeholder image with that hyperlink within the HTML of the email to make it look like it was a PDF, right? To make it look a little bit more believable to the victim that it's, a PDF. A lot of potential victims may not necessarily realize that PDFs can be malicious. They can contain JavaScript and do a lot of the same nasty things as other file formats. So just kind of an interesting approach, but kind of shows the myriad of ways that this functionality is being abused. Very similar, where we see a lot of different mouse spam lures. They pretend to be purchase orders or invoices or other financial related documents that victims would be interested in accessing, in an attempt to get the victim to access the content within the Discord or Slack CDNs to initiate that infection process. So that kind of walk through some of the delivery stage type of activity that we've really seen, the types of techniques that we're seeing in the wild. So let's talk about what happens during the infection process, because we're also seeing a lot of reliance on these same communications platforms throughout different stages of a typical malware infection. So here's an example where during the initial stage execution of a particular malware campaign, what we observed was the malware would reach out to the Discord content delivery network to attempt to retrieve content that would be used during the stage 2 execution of the malware. So you can see there's an HTTP GET request made out to a specific resource located within the content delivery network of Discord. And so you can see the response content returned to the victim is just an ASCII blob. Right, so if you're looking at this from a network traffic analysis perspective, right, you're not really seeing anything that's super indicative that this is malicious in nature. And that's because one of the steps that the adversary took to obfuscate their activity was they used an XOR-based obfuscation mechanism. So what would happen is they would retrieve this ASCII blob, they would reverse the XOR process, and then they would inject that into a process that they had started on the victim system. So they were using process injection. They would reverse the XOR to generate a usable payload, inject that into the running process on the system, and then execute that second stage. So in this case, that was associated with Remcos. If you're not familiar with Remcos, it's a commercially available remote access Trojan. It's developed and sold by a company called Breaking Security. A colleague and I did quite a bit of research into this organization and the different products that they sell. So if you're interested, get with me. I can drop you a link to the research we published there. But that's what the final payload was in this case. And you can kind of see right here is one of the examples of some of the registry keys that are created by the Remcos rat. In this case, one of the things that they do is they create a registry key, and then they drop the user's license key that they were issued by the company that makes this rat in there. So you can clearly see that this was a Remcos payload. So in this particular case, what they were doing was they were achieving persistence through the use of registry run keys. So persistence allows them to re-execute the malware each time the system reboots, which allows them to retain that foothold on the victim system across system reboots and things of that nature. So in this case, they were creating a registry run key, one of the most common persistence mechanisms we see, but they put a little bit of a twist on it, right? Instead of pointing directly to a Remcos binary, what they were doing was they were pointing that run key to a Windows shortcut file. So when you go and look at the Windows shortcut file, that's what actually was pointing to the malicious executable on disk. So each time the system reboots, Remcos kicks back off, establishes connectivity with the attacker's command and control server. In this case, they were using dynamic DNS-based server-side infrastructure to facilitate command and control, data exfiltration, basically stealing sensitive information from the victim and then exfiltrating it out to the attacker so they can attempt to monetize it. So here's another example in this case with an Office document. So this was an example of an Office document where they really didn't put a lot of effort into dropping any contents into the document itself. So there's no like decoy image. There's really no content whatsoever. We can tell by the file name used that this was a Turkish language campaign. And if you look at the actual file name itself, it's referencing Nitro codes, which are a product associated with the Discord platform that will allow premium features to be used if Discord users decide to purchase those. One of the common themes that we saw across a lot of the malware distribution campaigns was that the lures would try to entice victims to open the contents of malicious files by claiming to be a way for the victim to generate nitro codes to unlock those premium features without having to pay. So in this particular case, when you open the document, you can see there's a document open macro. So when the document opens, the macros kick off and begin executing code on the victim's system. In this case, they did a somewhat primitive obfuscation of the macro contents to try to make it a little bit more difficult to analyze what was actually taking place. But when you deobfuscate those macros, they're effectively calling the Windows command processor. They're using that to invoke PowerShell, and then they're using PowerShell to go retrieve the next stage of the infection process, in this case from the Discord content delivery network. So the additional components that are used in this case were also being hosted on Discord's content delivery network, so they could be retrieved during the infection process, stored locally on the system, and then executed to kind of kick off the next stage of the attack. In this case, it was an async rat campaign. And you can kind of see an example of what that looks like from a network perspective here. You can see the HTTP GET request that the macros in the document make, and then you can see the response content that's delivered by the Discord content delivery network server. You can see the MZ header and the DOS stub there. So clearly, this is a malicious executable that's being delivered when the Office document is opened by a potential victim. So here's just another example. In this case, a PDF. So this is meekmill.pdf. Not a lot of effort put into trying to craft contents within the PDF itself. In this case, it just says "I love you." When you open the PDF up, it prompts the user to allow remote content, and it shows that it's attempting to connect to the Discord content delivery network. And in this case, you can simply run strings on the PDF to get an idea of what's taking place here. You can see the app launch URL string there, and then you can see directly the URL to the malicious executable that's going to be used in the next stage of the infection process. So when the PDF's open and the user clicks allow, it reaches out to the Discord CDN, pulls down the next stage executable, and then kicks it off on the system, helping further progress the infection process. So not to be contained simply with Windows malware, we're also seeing this leveraged in IoT botnets. In this particular case, this was the QBot IoT botnet. This activity was consistent with what we've seen during and following the exploitation of some widely known, widely abused Yarn-based vulnerabilities. In this case, what the IoT malware was doing on the embedded Linux system is it was reaching out to Discord to pull down additional modules to infect the system with and join it to as a node within the IoT botnet. So we're seeing this across the board. It's across a myriad of different types of threats. Windows malware, even IoT malware. We're seeing the LUR documents use all of the same types of file formats we've grown accustomed to. Only in these cases, they're able to directly take advantage of organizational trust in some of these collaboration platforms like Discord and Slack. So let's talk a little bit about what happens after the infection process takes place. So let's talk about C2 and data exfiltration, right? Because most of the time when malware infections occur, the adversary behind the malware campaign has a mission objective, right? They want to try to achieve that mission objective through the use of malware distribution, infecting potential victims with malware for the purposes of something. With a lot of the malware that we see taking advantage of these platforms, it's financially motivated, crimeware. So in a lot of cases, the mission objective of the adversary is to try to generate revenue somehow by infecting systems across the internet, whether that's stealing sensitive information that they can then sell to or otherwise monetize, or through the use of ransomware, where it's effectively digital extortion, where they can generate revenue from victims by locking them out of their systems. There's a myriad of different ways that this is approached, and one of the key characteristics is that in a lot of these cases, there's some command and control mechanism that's required for the adversary to control those infections once they've achieved malware infection on a victim system. So one of the primary ways that we see this used by adversaries is through the use of what are called webhooks. So webhooks are effectively an API interface into Discord and Slack that allow Discord and Slack users to interact with the collaboration platform and with their server, their Discord server, their Slack instance, without having to install the client application on their system. So it's used for a lot of automation type tasks, right? You can create a robot that does certain things, and then you can use a webhook to communicate with that bot that may be present within the Discord or Slack server that you're using. So this is also an attractive mechanism for establishing a bidirectional command and control communications pathway with infected systems. We're seeing it used in a variety of different applications across the different malware that's being distributed around the world. So this is kind of an example of what a common Discord webhook might look like, right? You've got a URI structure. You can see discord.com, API, webhooks, and then there's an alphanumeric string that allows the communications to be brokered and to land in the location within Discord where you want it to, right? A channel in a server somewhere or something like that uses this same kind of format. When you think about it from a command and control perspective, right, it's obvious why this is attractive to adversaries. They don't have to stand up their own infrastructure. They don't have to maintain or manage server-side infrastructure, and they don't have to worry about their infrastructure being blocked as easily because they're taking direct advantage of legitimate platforms. So organizations that allow Discord communications are also going to allow communications with these webhooks. And here's another example, a similar type of concept just with Slack. It supports the same type of automation framework, and we see it used pretty heavily across the threat landscape. So here's an example of some of the communications that I captured when I was analyzing some malware that communicated with Discord post-infection, right? You can see this was captured with Burp, where I had an infected system and I was man-in-the-middling the HTTPS communications between that system and the Discord platform that the malware was attempting to communicate with. You can see this allowed the adversary to retrieve status updates. So as new system infections were achieved, as they infected new systems, those systems would reach out to the adversary over Discord, and they would spit a bunch of information about the system to the adversary so that, if the adversary is in Discord, they have a channel going, new infections are popping in, so they're seeing that information in real time as they're able to infect new systems. So you can see what that looks like deobfuscated on the right-hand pane there. In this particular case, they were giving a little bit of information about the system, and then they were giving them the portmap.io communications channel that the adversary could then connect to further administer the malware in this case. So Portmap is one of the most common traffic obfuscation mechanisms that's kind of become popular across a lot of the commodity malware we've seen. We've seen several instances where malware supports communicating with the attacker's command and control infrastructure over Portmap, or there's other solutions out there that operate similarly, like Ngrok and others. So the way that this works is that it enables the adversary to obfuscate where their server-side infrastructure is actually being located by using these services to broker the communications, to kind of sit in the middle and shield the victim from where their traffic is actually ending up. So the way this works is the attacker stands up their C2 server, and they establish an open VPN connection to the portmap.io platform. So when they infect a system with malware, the victim doesn't directly communicate with the attacker's C2 infrastructure. They connect to a specific portmap.io domain, and then the portmap service is responsible for providing that back-end brokering of the communications, that translation process, if you will. So the request is then forwarded on the back end to the C2 server itself, and any communications from C2 back to the victim are likewise obfuscated using this Portmap or Ngrok service. So you can see from an IR perspective or a malware analysis perspective, when you're looking at the malware trying to identify C2 infrastructure, all you're seeing is HTTP communications or other types of communications to the portmap.io service, and are unable to actually identify where that backend infrastructure may live. Makes it more resilient, makes it harder to take down, and makes it less risky from a law enforcement intervention standpoint. So one of the other interesting examples of command and control over Discord that I saw was through the use of Discord webhooks and WMI commands on the infected system. So the idea here was that the malware would write a batch file onto the system during the infection process. That batch file would be responsible for executing a bunch of different WMI commands to retrieve various information about the endpoint. That information would then be written into text files on the infected system, and then those text files would be read line by line and sent to the attacker's Discord server over a Discord webhook. So it was a bidirectional command execution response request type of channel that was established entirely using Discord webhooks. So you can kind of see an example of what this looks like dynamically here, where I've got an infected system that's running this malware. WMI is executing a daemon called Discord send webhook is running. That's basically reading those text files line by line and then transmitting them over Discord webhooks. And you can see an example of one of the post requests to this Discord webhook. You can see it's saying, please wait while the WMI commands are being executed. And then you can see as that WMI information is being read line by line, it's being transmitted. You can see the creation class equals Win32 _ operating system. So we see WMI used pretty commonly for survey information, collecting information about an infected system, and then sending it to an adversary as part of the bot registration process. So another example was with LEAKGAP, which is a pay to decrypt ransomware variant. So in this particular case, what they were doing is they were infecting the system with ransomware, and then periodically throughout the infection process, as the files are being encrypted, different status updates and ongoing updates about the malware's operation were being transmitted to the adversary over Discord webhooks. You can see, LeakGap info from, and then it has host name, password, and different information about the infected system. It's got key information that the adversary can use to manage the encryption and decryption keys if they have a myriad of different victims, and they need to keep that information straight so they know how to what key was used for encryption, so they can manage possibly providing decryption information if the victim chooses to pay the extortion demand. And here you can see another example of that, where the LeakGap ransomware is actually reporting that it's initiated the file encryption process back to the adversary so that they can see exactly where they are in the infection chain at any given point in time. So just a few different unique ways that we are seeing Discord used directly as a command and control channel for a variety of different types of malware out there. Again, it's very attractive because of the different functionality it provides. It's very robust. And it allows the adversary to take advantage of legitimate infrastructure. So if they were standing up their own C2, pretty easy to block the domain, the IP address, and things like that. But they're relying on the fact that a lot of organizations may not be blocking connectivity to Slack or Discord. So they're able to take advantage of that to circumvent, in a lot of cases, otherwise pretty stringent perimeter security controls. And so in the case of LeakGap, this is the ransom note that's being displayed. Fairly straightforward, just says, hey, don't reboot. Your files have been encrypted and your master boot record's been overwritten. Pay us this amount of Bitcoin to this specific wallet and send us an email with this key. Just as the extortion component of the ransomware itself. So I also want to talk a little bit about token and cookie stealing, because this is another area that we're seeing a lot of malicious activity. So let's talk about token stealers. So in a lot of cases, what we see is that the access tokens used to programmatically interact with Discord, Slack, other collaboration platforms are often stored in plain text on systems. So that makes them very trivial to grab. So if you're a threat actor and you're trying to get tokens so that you can impersonate users, so that you can leverage those tokens in your own malware to maintain some level of anonymity, you don't have to sign up for your own account. You can just take advantage of a victim's account. The idea here is that adversaries are infecting systems with these token stealers, often under the guise of game cheats or game cracks, to attempt to obtain that token so that they can use that token to further communicate with Discord in the context of the victim in this case. So they're very, very easy to implement because there's not a lot of client-side protection on these tokens. If you can get malware, if you can get code execution on a victim system and they've authenticated to one of these collaboration platforms and they have a token stored locally, that stealer can just grab that token, send it to the adversary, and then the attacker can directly begin to leverage the same tokens. So at this point, at the time that we really dug into a lot of the token stealing, there really wasn't any sort of client verification taking place. So not really anything that would pose a barrier to entry for this type of activity. So why would adversaries kind of want these sort of tokens? Well, there's a variety of different things that they could be used for. If you think about it from an adversary that's trying to infect other users with malware, being able to pose as one of those users' contacts likely maximizes the chances that they'll be able to entice the victim to open whatever sort of file they attach within Discord or Slack. Right? If you're a potential victim and you get a message from someone you know and talk to frequently, and they say, "Hey, I've got this Word document. Can you take a quick look at it?" Maybe you're more likely to open that document than if it was some random Discord account that you've never interacted with before. So by being able to take these tokens and then impersonate users, it allows them to more effectively social engineer other users of the collaboration platform. Likewise, it also allows them to register Discord webhooks and things like that. So I mentioned one of the most common kind of lures or themes we see with token stealing is the use of gaming related themes. So they'll often pose as game cheats or game cracks. In this case, this particular executable was called MaincraftGen. So they were posing as a Minecraft related utility that Minecraft gamers could use to benefit them some way in the game. So this was the main function associated with this particular malware, and you can see one of the things that it does is it establishes and generates a Discord webhook, and that's how it transmits back to the adversary. In this case, you can see webhook.send token. This is where it sends a lot of the information that the stealer is able to collect back to the attacker so they can then begin to impersonate the user. You can see this is where they're gathering the actual information on the system itself. And then, this is where they're actually sending the token back to the adversary. You can see them formulating the HTTP communications. So these are very, very readily available. They're pretty easy to write. So we see a ton of them. And here's just an example of a Growtopia themed stealer where they're doing something very similar, right? They're collecting the information, they're formulating a webhook request, and then sending it back to the adversary over the Discord webhook API, which allows the adversary to then begin to directly take advantage of that information by impersonating their previous victims for a variety of nefarious purposes. So Discord's not the only platform that this applies to as well, right? It's kind of been a theme here that, Discord's one of the most popular platforms, so we see a large amount of abuse in these various aspects of malware distribution, malware infection, post-compromise activities. But we're also seeing similar types of activity with Slack and some of the other platforms as well, right? As platforms get popular, they're typically not only popular for legitimate users, they often are also achieving increased levels of popularity with adversaries at the same time. Stealing Slack tokens is a little bit more complicated, but not by a whole lot. There's pretty easy mechanisms that can be used. Again, once you get malware on a system, you can steal the browser cookie, the D cookie, which is kind of the equivalent function within Slack as the Discord tokens I was previously describing. And once you gain these tokens, this allows you to download files. Even if they haven't had a public link created, it allows you to access Slack workspaces under the context of the compromised user. It allows you to impersonate the user to communicate with other members of their Slack instances, which is pretty powerful when you think about a lot of the use cases for Slack, right? It's used in a lot of corporate environments. So being able to obtain a corporate user's Slack token and impersonate that user is an interesting way that an adversary can attempt to gain an initial foothold in an organizational environment and then leverage that communications pathway to contact the help desk to reset passwords or otherwise try to maximize their sphere of influence. And there are also a lot of open source utilities that are available if you're interested in getting more information about how the Slack tokens work and testing some of the functionality that you can achieve using that. So that's a lot of information about the different ways we're seeing this functionality abused in various stages of the attack lifecycle. So what are some things that organizations can do? Well, the good news is that there are a lot of the same functions, the same security controls that we've typically recommended for other types of threats are directly applicable here as well. So ensuring that you have a comprehensive remote access solution and that you're employing things like two-factor authentication, where you're not just relying on token-based authentication, but you also have a second factor. Leveraging endpoint security controls, so making sure that you have the ability to detect malicious activity on the endpoint. I mentioned some of the attractiveness of these platforms is that they're inherently encrypted. the communications are taking place with legitimate platform infrastructure. So from a network perspective, it may be difficult for you to identify this at the network traffic layer. So in the case that this does get to an endpoint, it's important that you have that layered security defense in depth type of architectural strategy in place so that you can still detect when malicious code is executing on an endpoint, right? Making sure your users are aware that just because Discord and Slack are an approved communications mechanism doesn't mean they should inherently trust anything they receive via these communications platforms, right? Oftentimes users might think, oh, well, I use Slack, it's legitimate. There's probably some sort of comprehensive control in place to make sure that malicious content doesn't end up, in a chat with me somewhere. But the reality is we found that it's pretty trivial to host malicious contents on these content delivery networks, and they're not actively being taken down with any level of expediency. So in a lot of cases, the payloads will sit there for a long time. They're not being detected by the platform providers. So making sure that users are aware that this threat vector exists and that they're thinking about it when they get messages from people they don't know, or even if they're getting unexpected messages from people that they do know. Likewise, here's just a snapshot of some of the different security controls that you can deploy at different layers of your defensive architecture to try to provide that comprehensive defense in depth type of approach, making sure that you're inspecting the contents of emails, making sure that you're using NetFlow analysis to identify data exfiltration, that you're deploying comprehensive logging and centralized collection capabilities in the case of things like ransomware, making sure that not only do you have a comprehensive backup and recovery strategy, but that you have an offline backup and recovery strategy, and that you're testing it periodically to ensure that it continues to meet your recovery objectives as they change over time, right? Organizations aren't static. Their environments aren't static, and the systems that are important to the conduction of business objectives and mission objectives isn't static. So making sure that you're continuously testing that to make sure it remains effective as those requirements, as those needs change. And ensuring that you're deploying comprehensive network-based segmentation, that you're segmenting assets of differing importance in your environment goes a really long way, not only just for preventing positive compromise or preventing successful compromise in your environment, but that you're also maintaining the ability to detect if a compromise occurs and also more effectively respond to it. And that's where network segmentation, creating those inspection choke points, creating those places in the environment where you can strategically deploy defenses allows you to remain more agile in your response. It allows you to detect more quickly when things are going wrong before adversaries have a chance to operate towards longer term objectives once they get in. And it also helps you prevent that initial compromise from occurring in the first place. So just some things to think about that organizations should be thinking about when they're deploying security controls, when they're architecting their solutions. Likewise, if you're an organization and you don't use Discord for specific official company communications, you should probably think about blocking communications with the Discord platform altogether. Likewise, if you don't use Slack, the same applies. If they're not used in your environment, don't think that just because they're legitimate platforms, there's no risk associated with them. Because as I've kind of demonstrated during this presentation, we're seeing adversaries take advantage of this across pretty much every major area of your typical type of attack. So something to keep in mind. Least functionality, least privilege concepts are definitely the way to go here in terms of, they're difficult to inspect. So if you don't need them, go ahead and just prevent the communications altogether, because it'll, remove an entire, mechanism or method or technique that adversaries are finding increasingly attractive nowadays. So shameless pitch, right? I work for Cisco Talos. One of the things that we try to do is we try to make as much information available to the general public as we can when we see this sort of new type of attack or new malware or new techniques being used, and we try to put that information out there for the global security community. Not just Cisco customers, but anyone who's interested in staying up to date on the latest types of threats that we're seeing, the latest types of research that we're doing. So here's just a few ways that you can kind of stay up to date via social media, our blog, podcasts, things of that nature. So definitely encourage you to check that out if you find this sort of topic interesting and want to stay up to date on the latest and greatest types of attacks that we're seeing in the wild. And with that, I will open it up for any Q&A. I will be in the Discord channel for the track. So just let me know if you have any questions or anything like that. Thank you so much for the time. I really appreciate it and hope it was helpful. Stay safe out there.